So a polynomial looks like this, a bunch of constant a0, a1, a2, a3 up to an. This thing is called a degree n polynomial. When n is 2, you have quadratic function, then usually we write ax squared plus bx plus c. That means a0 here is c, a1 is b, and a2 is a, okay? And if n is 1, we have this thing, which is a linear equation. So this is a straight line, okay? And then in this expression, a is the slope, and negative b is the y-intercept. So basically, it's just something like this, or something like this, okay? Or something like this, okay? These three are linear equations. Again, this is not an equation. Why? This is not even a function. This do not fulfill the definition of function. 1x give you 1y. This particular thing, 1x give you infinite number of y. So no, this is not a function. But these three all are function. And particularly, this one is both injective, surjective. This one is also same injective, surjective. This one is not injective because there are many x give you the same y. This one is also not surjective because let's say y is 0. No x give you y to 0. Okay. And then for quadratic equation, you will have what? You will have something that looks like this. Okay. Or you can have something that looks like this, or you can have something that looks like this, okay? Similarly, you can have the negative part, negative part, negative part, okay? So these are all quadratic functions. Conjugate root occur in pairs, so this is the general formula for solving quadratic function. It is possible that b squared minus 4ac is smaller than 0. Then this guy will be a complex number. So this means you will have what? You will have some real part, I call it a, and then this is an imaginary part, so in the end you have a plus bi, okay? So this is what? Conjugate pairs. Previously, I said that if you have a z here, the conjugate is just mirror image along the x-axis. So this means conjugate pairs. And if this part is larger than 0, then this thing, you are doing something square root larger than 0, then you only have one number. Then you can imagine this 2 point, what? Move towards this line. Then this is the real line, right? So when this guy is larger than 0, so it means your root is on the real line. And then for any degree n polynomial with complex coefficient, there's always n roots, okay? And two gentlemen prove that there's no way you can have a algebraic solution for polynomial degree equal to 4. These two do not conflict with each other. So this one is saying that there's no formula like this for polynomial with degree larger than 4. This is saying that there is root. This is saying that for degree larger than 4, we don't know the expression of root, okay? So basically this one says that there exists the root, okay? This one basically means we don't have formula, okay, for the root. We don't have formula does not mean the root does not exist. So these two do not conflict with each other. And you may wonder why this is true. If you study cryptography in year 3, you will touch something called Galois theory. Then you will know why. Okay. Lastly, we have something called conic section. Imagine a cone like this, and then you chop this thing. Then you have something on the surface. This shape has the following form. Imagine if you chop it like this, then you will see a circle. Good. Then you see a circle. If you chop it slightly like this, you will see a shape like this. And if you view it from this angle, you will see an ellipse. And if you chop it like this, okay, then you will see a thing that looks like this. So if you look at here, you will see a function that looks like this. So this is what? A parabola, okay? It means that all the hyperbola, parabola, ellipse, circle are special form of this. What you learn in high school or A-level or other related math, you will have this equation. Later in linear algebra, you can write this thing in this form. So it's something called a quadratic form. You have a vector x, which represent x, y, and 1, and you have a matrix A holding all these A, B, C, D, E, F here, equal to 0. So that means if you have a way to describe this matrix A, you can tell this thing, is it a circle, is it a hyperbola, is it a parabola, and is this a ellipse? These are the details. After you study linear algebra, come back to here, you will understand what are these things. And basically, it's saying that you can either have circle, ellipse, parabola, like this, okay? And you can also have hyperbola. So it means something like this, okay? Y equal 1 over x is an example of hyperbola, okay? So these are the 1, 2, 3, 4. These are the 4 types of things you can see, okay? Of course, you can say in the extreme case, this parabola becomes so narrow, it almost looks like a straight line. It's still a parabola, okay? Similarly, if the radius of this circle go to 0, you only see a point. So this corresponds to what? It corresponds to you are chopping near the corner, then you only see a point. But still, it's a circle, okay? So next part will be partial fraction and rational function. I will skip this for now. This is a very useful technique for doing integration. The idea is you have this particular thing, you can split it into this form. So the main focus here is how do you go from here to here, so that if you do integrate this thing, you can integrate them one by one. I will talk about this when we go to integration of partial fraction. Now, some of you may not know about this symbol, so now let me tell you what is this. So this symbol, you will have a thing here. This is the object you need to work on. You have an index k. You can write anything here. You can say I write I here, then you can write I here. You write L here, then you write L here. Okay, so this is like index. So if I write K, I write K, and then I will have what? A starting point and an ending point. So if I write 2 and this is 3, then it means A2 plus A3. this thing means plus. Okay. Similarly, you have a product. Okay, like this. Then this is A2 times A3. Okay, as I told you, try not to use this symbol, but use a dot. Okay. For example, if you have this, there's no subscript. So that means you repeatedly add A 3 times from 1 to 3. And if you have AK, that means the K have to change. So you have A1 plus A2 plus A3. You can add stuff on here. So for example, you have log AK 3 to 5, then you have log A3 plus log A4 plus log A5. And you have something that looks like this, then you keep working on this. And this is like the one you see in the lab, okay? And you can also have this. So K plus 1 as the denominator, add from 1 to 100. So you have this plus this plus this plus this up to 100. You can never compute this by simple addition. You can try to add 100 of them, but it will take you maybe a whole day. And this is why we previously talked about partial fraction. If you work out the partial fraction, this thing is equal to this thing. Okay, I didn't tell you how you get this, but let's say this is true. This term, because of this thing equal to the red box, so this thing is 2 terms. So now I have 2 terms. Then I just repeat this for k to 1 to 100, then I will get this. And now here's the funny thing. This is negative half, this is plus half, so they cancel out. This is negative 1/3, this is plus 1/3, so they cancel out. Now you see I will cancel out all things. In the end, I will have the first guy and the last guy. So I get this. So I have a way to compute this thing. This thing is called telescoping sum. It's a very powerful technique for handling this kind of thing. You may wonder, is there an advanced version of this? Yes, this is called Gauss-Burst splitting. The next part will be trigonometry. That means sine cosine. So if I have a triangle here, this is right angle, okay? This is theta, okay? Then sine is this part divided by this part, cosine is this part divided by this part, and tangent is this part divided by this part, okay? So basically it's this, okay? And then you also have the three reciprocal one, secant, cosecant, cotangent. It's just name, okay? And then you have the following, sine square plus cosine square equal 1. This is Pythagoras theorem. And similarly, because of the relationship here, you divide the whole thing, let's say, by sine square. So sine square divided by sine square is 1, this one. And then if you divide the whole thing by cosine square, then cosine square divided by cosine square will be 1 is this one. Sine divided by cosine is tangent, but you have square, so you have tangent square. 1 over cosine is secant. Now you have a square, so you have secant square, so you have this one. Okay? And now here's a bunch of formula. If you have studied further math or A-level math or whatever IB, AGCSE, A-level, you probably know this kind of formula. If you don't know any of them, so don't worry. If I have to test you this in the exam, I will give you the formula. And you also have the complex version. This is the one I told you. This actually is the most useful one, okay? And then now, from the sine cosine, if you add an h, it means hyperbolic. This module, you don't see them, but if you study ODE, ordinary differential equation, you will see this bunch of things, which basically is just you put a I inside the sine cosine thing. Yes, that means you put a complex imaginary unit I inside the sine cosine thing. Suddenly you have a parallel version of this. And then here are more formula, which you don't need to know of them. Doesn't matter. I just show you this formula here. Okay.